Okay. So yeah, as I said, let's discuss about uniform motion, how to plot graph of uniform motion once again. So in uniform motion, basically means when a body is moving in a straight line and it covers equal distance in equal interval of time. One day I was like actually going to airport in a cab, and I saw that in the speedometer in the cab, the speed was showing like it was written 100 kilometer per hour. Okay, and that was not changing. It was like almost fixed. I observed for a long time on that highway. It was not moving, like the speed was not changing. It was fixed at 80 kilometer per hour. So can I say in that interval of time, body was moving at a uniform motion or exhibiting a uniform motion?
Yes, sir.
Okay. What if I drop a pen or a ball from the 13th floor of my building? It comes down. Okay, it obviously goes down, but then in that case, can we say that it is moving with uniform motion? If I drop a ball from 13th floor of my apartment, as it is going down, does speed change or it remains the same?
Increases.
The speed does not remain same. Okay,
Yes,
so
sir.
for such motion, can we say it's a uniform motion or it's not a uniform motion?
Uniform motion.
It is not a uniform motion, right? As it is going down, no, the speed keeps on increasing. So it does not maintain the same speed. Okay. Now for this kind of motion, uniform motion, we are interested in two things mainly, like how the displacement time graphs look like and how velocity time graph look like. All right. So let's take an example, as I said. So here we have two scales. Okay. Now the top scale is going to measure the displacement, like what is the displacement covered by the object. Okay, you can see it starts from 0, 1, 2, 3. It means when the object is here, okay, object in this case would be a car. So when object is here, it means it has no displacement. Displacement is 0. When it reaches here, it is having a displacement of 2, or when it reaches here, displacement, sorry, here it's 1. Here the displacement is 2. Here it's 3 and 4. So as car is increasing, the displacement increases. Okay, also here the displacement is actually, let's say, given in meters. Okay, I haven't written that, but okay, let's assume that is in meters. The lower axis, the lower line which you see, that is for time, and time is changing from 0, 1, 2, 3, 4, 5, 6, and this measurement is given in seconds. Clear? We have a graph paper on which we are going to plot displacement versus the time relation. Okay, so I'm simultaneously going to demonstrate you how the actual car is moving or the object is moving and how the displacement time graph looks like for a uniform motion. Okay, so here we have a car which is at displacement 0 when the time is 0. So it is at the starting point. The displacement is 0 when the car, when the at time t is equals to 0. How do we plot this information on this graph paper? Okay, can you see that red dot over here? This means, okay, when the time is 0, displacement is 0. Moves further, like it moves forward to point 1. At point 1, when it reaches point 1, okay, see point 1 means when time is 2 second, it travels 1 meter, totally like it travels 1 meter. Okay, that on the graph we can write like this: for 2 second, displacement is 1 meter. Clear? When this reaches 2 meter, time is 4 second, or at 4 second time it travels 2 meter. That on the graph can be plotted like this: at 4 second it has reached 2 meter displacement. Okay, at time 6 second, again it has reached 3 meters. At 8 second it reaches 4 meter. At 10 second it reaches 5 meter. At 12 second it reaches 6 meter. At 14 second it reaches 7 meter, and at 16 second it reaches 8 meter. This car is actually just moving in a straight line. Okay, it's just going forward in a straight line. But when we draw the displacement time graph, the displacement time graph goes in upward direction. Okay, so to complete the displacement time graph, we can just put an arrow like this, and this is our displacement time graph for the motion. So the displacement time graph is going along the, like, is an inclined line. Okay, it's just going up. Displacement time graph being inclined does not mean the car is moving in that inclined direction. Car is moving in a straight line. It's a motion in a straight line. See, you check, like the displacement changes and it changes uniformly. Like, can you tell me, like, in every 2 seconds, every 2 seconds. By how much distance the body moves forward? Uh, every 2 seconds, by what distance or displacement the body moves forward?
1 meter.
1 meter, right? So it's just going forward by 1 meter. Okay, therefore, in 1 second, how much it moves forward by every second?
Half a meter.
Half a meter. Okay, so Tananya, is that half meter consistent, or is it like changing for different part of the journey? I mean, like you take 1 second from any like part of the journey. In that 1 second, is it always moving only half a meter,
It's only moving half a meter.
irrespective of which 2 seconds you are taking?
Yes.
Okay, so this is the point which I want you to understand. That is why this is called as uniform motion. No matter which 2 seconds you take, you can count between 8 and 9 seconds, or you can count between 11 and 12 seconds. Okay, or you can count between 15 and 16 seconds. So you just check between any 2 seconds. It always travels half a meter. You have the displacement time graph, which is an inclined line. It is an inclined line which is going upwards. Okay, like the inclined line means it is moving at a uniform speed. Displacement time graph. Velocity is can be calculated for such kind of motion, or for any like any displacement time graph. Velocity can be calculated by measuring slope of the displacement time graph. So in order to calculate velocity, we just need to find slope of this graph. Okay, how do we calculate slope? For calculating slope, you just take any two random point on the graph. So I chose to take this point here as A and this point as B. Okay, now between A and B, connect them by drawing a horizontal line from A to B and a vertical line from A to B. Clear? Okay, let's mark this point also. This is C now. The vertical length BC divided by the horizontal length AC. You can do this between any 2 points. I've done it between A and B. Okay, can you tell me how much is BC then? I think there are four boxes between B and C. So it's going up by 4 units, like from 2, it's going up to 6. So can I say BC is 4? Similarly, how much is AC? 1 box, 2 box, 3 box, 4 box, 5 box, 6 box, 7 box, 8 box. So it's going 8 units from 4 to 12. Okay, therefore BC is 4 meters, okay, displacement in meters, and AC is 8 seconds. And hence velocity is 0.5 meter per second. See, for the same motion, like for the same journey, what we did from 0 marking to 8 marking, I was also interested. Can we just draw a velocity time graph and see how that looks like? So here I've brought another graph paper. Okay, down we write the time, say marking 1 to 15 seconds. And across, like on the y-axis, we writing velocity. Okay, in this case, as you see, velocity is not changing. Velocity is constant. Okay, and what is that value? It is 0.5 meter per second. Therefore, the velocity line does not go up or down. See, line going up means it's increasing. Line going down means it's decreasing. But the velocity time graph here, okay, I just made the marking 0 0.5 here at this point. And this is how the graph looks like. It's a straight line. So for the same motion where the car is going in a straight line with uniform motion, displacement time graph is an inclined line. It's going up, while velocity time graph is a horizontal line and it's going straight, like horizontally. Clear? No problem with this? Okay. And in this case, like this is the speedometer in your vehicle. Suppose if you're going in this car and observing the speedometer, you'll find that the speedometer, the needle does not fluctuate. It does not go up or down. It remains constant. Clear? Okay. When we were doing questions in the last class, I also felt that there was another case which confused you a bit. Here I'm changing the situation. Now here you see the car is at position 8. Okay, it's already where it is at position 8 meter. That means the initial displacement is 8 meter. Now how do we decide the displacement? See, you can think that there is a person standing here and he is the observer, right? So that person is observing the position of the car. So initial position of the car means initial displacement of the car, like initially where it is. Okay, so on the graph paper we can plot the point like this. At 0 second, this was at 8 position. At 2 second, it is at 7 meter position. At third second, it is at 6 meter position. At, okay, it is coming back. So it is at 5 meter. Okay, then it is at 4 meter, and then it's at 3 meter, then it is at 2 meter, and then it has 1 meter and 0 meter. I'll just do the marking accordingly so that you don't get confused with the timing. So as far as time is concerned here in seconds, this is 0, 2, 4, 6, 8, 10, 12, 14, and 16. Decline line means that the car is started from a distance which is far away from the observer and it's coming behind. Okay, so now the displacement time graph can be completed by an arrow, and velocity here is slope of the displacement time graph. For finding the slope, as I said in the previous case, mark 2 points on the graph, A and B. Then draw a horizontal line connecting A and B and a vertical line between A and B. Slope is the ratio of the vertical line, which is BC in this case, divided by horizontal line, which is AC in the same case. BC here is minus 4 meter. So in simple language, see, whenever the object is coming closer, it's like velocity is negative. When the object is coming towards the observer, in that case, velocity is negative. And if it's going away from the observer, velocity is positive. Clear? So, yeah, the velocity time graph, like if we try to plot, now velocity is minus 0.5. It's not plus 0.5. So ideally it must be below the x-axis, but I've just used the same graph. That's why I've written here. Okay, just be careful. I mentioned here minus 0.5. So velocity is negative 0.5 because it's coming back, right? Displacement is decreasing. And it is again a straight line horizontal, which is parallel to the x-axis. Simple. Even in this case, when it's coming behind with the same speed, you'll find that the speedometer in the car does not change. Let's see. Okay, please see the question. It says a body is moving in a straight line and its displacement at various instant of time is given as following. Plot the displacement time graph and calculate the distance traveled in the interval of 1 second to 5 seconds, and also the average velocity in the time interval 1 to 5 seconds. I think first target is to draw the displacement time graph. At 0, the displacement is 2. So this point here. At 1 second, displacement is 6. Okay, tell me if I'm doing it right. Okay, is that correct? At 2, the displacement is 12. Third second. Third second, do I draw it here, Vanshika?
Yes, sir.
Are you sure?
No, the third second says 12, right?
12. So here only.
Yeah,
And then for the fourth second,
that's also 12.
12. Then 18. So we go higher here. And then sixth second, 22. So we go further higher. And then seventh second, it is 24. So here. So this is how it looks like. Okay, let's connect these dots with a line. Okay. So the line is not exactly going up, is what I understand. Like it is sometime going up, but sometime it also becomes horizontal and flat. What does that tell you about the motion? Okay, can you briefly summarize the motion? Like how is it moving?
It's non-uniform motion.
It's a non-uniform motion, right? Because it's not maintaining the same okay speed throughout. Okay, like for example, 0 to 1 second, it travels from 2 to 6, means it travels how much? Like it travels 4 meters. Okay, 0 to 1 second, it travels how much?
Four,
Isn't it 0 to 2?
0 to 1. 0 to 1, how much it is traveling?
4 meters.
0 to 1, it is traveling 4 meters, like plus 4. And 1 to 2, from 1 to 2, how much it's traveling?
6 meters.
6 meter plus 6, right? It goes
Yeah.
up. So even though it's increase, like it's going away, like all through like 0 to 2 seconds, first 1 second it's only traveling 4 meter, but the next 1 second it is traveling 6 meter. So there is change in velocity, like the velocity is not same. And then from 2 seconds till 4 second, Is there any change in displacement?
No.
So in this part of the journey, w- what is the nature of motion? Like, is car moving or is the object moving during that time? What does that horizontal line signify? Is it moving? It just means that it is at rest. Do you all agree? See, from there is no change in displacement. Okay, so if displacement is a horizontal line, it means that it's not moving, it is at rest. Okay. Now, all through 1 to 5 second, what is the total distance traveled by the object? Starting from 1 second to 5 second, in that interval, sorry, 1 to 5 second, yeah, in that interval, what is the total distance traveled by the object? 1 to 5 second, what is the total displacement? See,
So
at
do
one,
we add everything?
at 1 it was at a distance of 6, and at 5 it is at a distance of 18. So we just subtract these two. At 1 second it is at a distance of 6 meter, and at 5 second it is at a distance of 18 meter. So we just subtract that to find from 1 to 5 how much, like between 1 and 5 how much it travel. Okay. On the graph paper it can be understood like this also, that from 1 to 2 it goes like 6 meter, then 2 to 4 it does not move at all, and then 4 to 5 it goes another 6 meter. So 6 plus 6, 12. So the total distance travel, like the first part is it is okay, total distance is 18 minus 12. Okay, so it is, sorry, 18 minus 6, not 18 minus 12, 18 minus 6, it's 12 meters. Second part of the question says find average velocity. Okay, so for this part, just for the new students here, I like to mention average velocity is nothing but total displacement by total time. Like, what is the total displacement during the journey, like in 1 to 5 second, divided by time. So total displacement is this, what we calculated in the previous part, like it is traveling 12 meter. Okay, see, in some part it was traveling fast, and some part it was at rest, some part it was traveling slow. So here, total distance, like on an average, what was velocity? So total distance 12 meter divided by total time. So 1 second to 5 second, total time is 4 second, like 5 minus 1, 4 seconds. Okay, therefore 3 meter per second. That's your final answer. Simple. You need to help me understand first, okay, and then solve the question. Explain me how to do the question.
Okay. From a displacement time graph given, for cyclists given the figure, find the average velocity in the first 4 seconds. For- So average velocity is equal to total distance upon total time.
Okay,
Um, Distance is
so in the first question, part of the question, they're asking us to find average velocity in the first
4 seconds.
4 seconds. So yeah, as you said, average velocity is total distance by total time, or total displacement by total time. Okay, so in 4 seconds, total time is okay, 4 seconds. What is the total distance travel, displacement travel? See, when body is moving in a straight line in one direction, distance and displacement is same. So please don't get confused with that. But only if it is going in straight line, not when it is returning back, then things changes. So 1 to 4 second last year, what's the distance travel or the displacement? Okay, let me break the journey for you. Like 0 to 1 second, how much it's traveling?
0 to 1 second.
Yeah.
Traveling.
What is the displacement at the end of 1 second? Like at 0, displacement is 0, right?
Yes,
At 1, what's the displacement?
it
See,
is 5.
it is 5. This is the observer.
Okay.
At time t is equals to 0, cyclist is here. Like it's at 0 displacement. At time t is equals to 0. Okay. Now, at t is equals to 5, sorry, t is equals to 1 second, it reaches here. T is equals to 1 second. It reaches a distance of how much? 5 meters from
Yes.
the starting. Okay. So maybe like on the distance scale, this is 0 meter, this is 5 meter from the starting. Clear? At time t is equals to 3 seconds, it reaches this distance, like 10 meters. Okay, can you understand like how the cyclist is moving?
Yes, yes,
After that, like from 3 to 5 seconds, it stays here only. Like 3 to 5, it stays there only. Like at t is equals to 4 second, or also he is here. T is equals to 5 second, also he is here only.
yes.
Correct? After that, if you see, this displacement is decreasing. What does this mean? What
Like
does
it's
this?
going.
It's coming closer.
It's coming closer to the observer. This is the observer line, right? So it's coming behind now.
Okay.
So at t is equals to 6 seconds, he reaches 5 meter again. And at t is equals to 7 second, okay, he reaches actually the starting point. Like this displacement becomes 0.
Yes.
Okay, so now can you relate with the understand like the graph? Okay, after this, it becomes more interesting. If you look at further part of the journey, here the displacement is minus 10. What does minus 10 mean in this case? At time t is equals to 9 seconds, okay, displacement is minus 10. That means it has gone in opposite direction. Okay, so the cyclist actually reaches somewhere here at t is equals to 9 second. This distance is minus 10 meter. Clear? At t is equals to 10, t is equals to 11, and t is equals to 12, it waits there, like at that position. Clear? And then it returns at t is equals to 13, it returns back to the mean position, the starting position.
So at t is equal to 6, it is at 5 meters, right?
Yeah, yeah, it is at 5 meters.
Okay.
And then at 7, it is at 0 meter, means it
Yeah.
came back to the starting point. After 7 to 9, it is going in opposite direction. That is why displacement is negative.
Like it's going backwards.
Huh,
Even.
backwards only, but from 0, it is going in opposite direction.
Okay.
Like, see, this side of the displacement is positive. We take this side displacement as negative.
Okay.
Fine. Let's just try to do the question. Average velocity in 0 to 4 second. So what is total distance traveled in 0 to 4 seconds? Up till 4 second, what is the total distance traveled?
5 and 10.
Not 5 and 10. Like, see, this is 5 and then 5 more. Okay.
So 10.
So totally 10 only.
10.
Like at like from the starting till this point is 10 meter at
10.
4 second. So just 10. So it is 10 meters. Okay, 10 by 4 is 2.5 meters per second. Simple.
Yes, sir.
Okay, second part of the question says, what is displacement from the initial position at the end of 10 second? So at the end of 10 second, what's the displacement from the initial position? At 10 second, what's the displacement?
Minus 10.
Minus 10. That's it. So you can directly say minus 10. That's your answer.
Okay.
Okay, plus 10 means on the right side, so minus 10 means on the left side. The time after which he reaches the starting point. So after he left the starting point, I can see in the graph that after at 2 times he's reaching back at the starting point. So when he reaches back to the starting point?
At 7 and 13.
At 7 second and 13 second. Very good. Simple?
Yes, sir. Understood.
Sir?
Yes.
Sir, I didn't understand the minus 10. Where do you get that?
The minus 10 part. See, here generally like in most of the question we see that the displacement time graph is given in the first quadrant, like above x-axis. But in this case, I saw after 7 second the displacement started becoming negative. Like A to B, it's going away, like it's going far away like this, 5 meter. B to C, it goes further, 5 meter. Okay. Then C to D, it takes a rest. It does not move, so it stays here only. D to E, it's returning back, so it returns back. At 7th second, it reaches this displacement becomes zero, right? So it reaches its original position. But after that, I see the graph is going further down. Okay, going further down means it is becoming more negative, correct? More negative means it's going in the opposite direction.
Yes, sir.
That is what minus 10 means. That minus 10, it's reaching, like it's going in the opposite direction. Simple.
Yes, sir.
Is a falling object. Okay, it's falling towards Earth. Okay, this is displacement and this is time. Okay, so this object starts falling from this height, and at this height, its speed is like it is just dropped from there, so its speed or velocity is zero. But does speed remain same as the object falls down? Actually, the speed does not remain same. The speed increases. So after some time, like if maybe 1 second or so, if you observe, speed becomes 10 meter per second. Then the speed becomes 20 meter per second. So imagine you are sitting in a car and you're focusing like on the speedometer, and the speedometer, the speed is increasing. So you are sitting in a car, the car started from rest, and whoever is driving the car is accelerating the car. So the speed increases. Now just apply your general assessment skills and tell me. The speed is increasing for 5 seconds, let's say. For 5 seconds, the car speed is accelerated. Now the distance traveled by the car in the first 1 second, like 0 to 1 second, will that be more, or the distance traveled from 4 to 5 seconds would be more? See, this is a car. It's accelerating. At time t is equals to 0, it starts accelerating. And it accelerates till 5 seconds. Now in 0 to 1 second, it will travel some distance. It moves forward by some amount. And 4 to 5 seconds also, it will move forward by some amount. So my question to you is like, which of these two displacement is greater? Is it like 0 to 1 second wala displacement, or 4 to 5 seconds displacement?
So 45.
4 to 5. All of you agree on this point, right? Harika, is it 4 to 5 or 0 to 1?
So 45.
And why is it so, Harika?
Because it's increasing
What is increasing?
the displacement.
Oh, that is increasing. That is increasing between 0 and 1 also, and it is increasing between 4 and 5 also. That is not my question. My question is why the increase in 4 to 5 is more than the increase in 0 to 1?
So because it's greater.
What is greater?
So the speed.
The speed is greater. Yeah, between 4 and 5 second, the speed is much higher because the speed was continuously increasing. So 4 to 5 second is an interval where the speed is greater. So that in the first second, that first interval of time, 0 to 1 second, the distance traveled would be lesser because the average speed at that time would be lesser as it has just started. But the average speed in 4 to 5 second would be much higher as it has already gained a lot of speed. And same can be said about this ball which is coming down. So as the speed is increasing, I can say that 0 to 1 second, okay, it will travel some distance, but 1 to 2 second, it will travel greater distance. So whatever distance it travels from 0 to 1, because it was slow in that part of the journey, and 1 to 2 second, it is becoming a little faster. The speed has increased, and therefore the distance which it travels keeps on increasing. So at 0 second and 1 second, suppose it travels this much distance. Okay, this is like what, like maybe let's say 3 meters. Certainly, see, I'm taking all these random values. Certainly this would be more than that. So if that is 3 meter, maybe this is 5 meter. Okay. Maybe 0 to 1, it's traveling this much. Now 1 to 2, there will be greater displacement, and 2 to 3, there will be greater displacement. Okay, so 0 to 1, it's going up by this much, like the displacement is increasing by this much. 1 to 2 second, it's increasing by this much. I can clearly see that this length, the increase in displacement, is more than the displacement change in 0 to 1 second. And then 1 to 2, 2 to 3 second, the displacement increases, and here the displacement increases by a greater amount. Okay, so this and this. Let's join these. And can you see the graph is actually not straight, it is a curvy line. This graph is also called a parabola. So this represents a uniform motion, and it's a like so it represents an accelerated motion where the speed increases. So in that case, distance does not increase uniformly every second, but rather in consecutive interval of time, the displacement becomes greater and greater. It's increasing. Okay, just that graph part. I'll quickly try to help you understand if someone is confused. Okay, I'll do it on the graph and the object together so that it becomes clear. Okay, just imagine this is your object falling down. So this is at t is equals to 0. Displacement is also 0. Okay, this is displacement axis and this is time axis. Okay, the object is going down, but I'm taking the downward displacement as positive. So this now is my object. Okay, now after some time, the same object reaches here. So let's say at t is equals to 1 second, displacement increases to some value, like from 0 it became 5 meter. But now during this journey, the speed also increased. Okay, so speed is increasing means in the next second, so 1 to 2 second, it is going to travel greater distance. It's going to travel more distance because the speed is increasing during the journey, right? So let's say 15 meters. And same at 3 second, it will travel maybe another more. Like this time it traveled 10, next time another maybe 15 more. So if I plot this information on a graph paper, at 0 second displacement is 0. At 1 second displacement is 5. Okay, 5 here. At 2 second, 2 second, okay, it's not 10, it's 15. Okay, at 2 second it's 15. So if I join these line, the line is not doesn't keep going straight. It start curling. Okay, so this happens when the speed continuously increases. Displacement time graph is a straight line, is a curved line. It's a curved line. It's like a parabola. What is velocity time graph? This graph is velocity along y-axis and time along the x-axis. So like along the x-axis, we draw time in seconds or any other unit. And here we write velocity in meter per second. Suppose velocity time graph is like this. You remember how I calculated slope for the distance displacement time graph? I just said take 2 points on the graph, draw the horizontal line, draw the vertical line. Okay, let's say this is A unit and this is B unit. Then slope is given by formula A divided by B. For the displacement time graph, if we calculate slope, we used to get velocity. For velocity time graph, if you do the same, the slope, you actually get acceleration. Clear? So this is something you need to remember. In velocity time graph, if you divide, like you find slope, you get acceleration. And in velocity time graph, if you find area under the curve, that also gives you displacement. Okay, I think if we see this through a question, it will be better to understand. Suppose a body is moving in a uniform speed. Okay, then then velocity time graph, as I saw in that first example today, is a horizontal line, and this horizontal line goes like this. You agree with me? 5 meter per second. So this is for uniform motion, right? Tell me, what is the distance traveled by this object which is moving at a speed of 5 meter per second in 10 seconds? What is the distance traveled by this object which is moving at a speed of 5 meter per second in 10 seconds? Car is moving at 5 meter per second and it does so for 10 seconds. So in 10 seconds, what is the total distance traveled?
So it's like
50.
50 meters.
50 meters. velocity is 5 meter per second. It is maintaining that 5 meter per second for 10 seconds. So 5 into 10, 50. This is common sense, right? Now let me just complicate this simple thing. Okay, I can also tell you that, see, just do this. Like, you have drawn the velocity time graph 5 meter per second for 10 seconds. Okay, just if you want to find the displacement in 10 seconds, find this area under this graph. Find this area under the graph between 0 and 10 seconds. So area, it's a rectangle, it's clear, it's a rectangle, and rectangle area is length multiplied with breadth. Length is 10 seconds and breadth is 5 meter per second. Second cancel. If you multiply, you get 50 meters. So can I say, like, just find the area under the graph to find the displacement? But what is your immediate thought? So you're just making things complicated. It was simple otherwise. We were already understanding it. You're just complicating it by putting that area there, isn't it? You can say yes. It's yes. Yeah, it is like, I can agree upon that in this scenario. Actually, just directly thinking was better. But now just think of another scenario here where the object is not moving at constant speed but at an increasing speed. Means it starts from rest at a 0 meter per second, and in 5 seconds, okay, so just think you're driving a cycle. You start the speed of 0 meter per second, and in 5 seconds you reach the speed of 10 meter per second. Okay, during this time, okay, in this 5 seconds, your speed was never fixed. It was continuously increasing from 0 to 10 meter per second, right? That's what the graph is telling, right? That 0 to 10, 5 second speed was constantly changing, it was increasing. Okay, just imagine you started cycling. Okay, you started a cycle from your house, and then the speed, and you started pedaling. So in 5 seconds the speed increased from 0 meter per second to 10 meter per second. Okay, in this case, if I ask you, what is the distance traveled by, okay, in that time? Okay, I'll give you some options for the answer. Can I say, like, for distance, just do speed multiplied with time? So you travel 50 meter. Is this logic correct? Situation. In first situation, that car or the object or the cycle was moving at a fixed 5 meter per second. The speed was not going up and down. In this case, it starts from 0 meter per second and it slowly reaches a 10 meter per second speed. And it is in that final second, the last second, that the speed was 10 meter per second. Throughout the journey, speed was not 10 meter per second. So is it correct if I multiply 10 meter per second with 5 second? Does that sound right to you?
Yes, sir.
No. Because that 10 meter per second was not constant speed. If it was constantly moving at 10 meter per second for 5 seconds, then we multiply, that makes sense. This is just starting with 0 and it only reaches that 10 meter per second in that very final moment. Okay, it is not even a second that it maintained 10 meter per second. In fact, that was just a final moment when it was 10 meter per second. Clear? Now you're driving a scooter and or a cycle, and the speed increases from 0 to 5 seconds. It is continuously increasing, like you have just started accelerating it, so it's continuously increasing. So in this 5 seconds, the speed is not constant, it is changing every moment. If you have like a slow mo recorder and you analyze it later on, you realize that every single second the speed was increasing. It was never constant, it was never 0, it was never 1. It was only 1 meter per second for one fraction of time, like, okay, and same goes with other values between 0 and 10. So in this case, I don't know what speed to multiply with time to actually get the distance, and this therefore is wrong. Okay, this is completely wrong. So in this case, that other logic works really well. Just find the area under the graph. Okay, just find the area under the graph and you will get the displacement of the object, like area under the velocity time graph. So 0 to 10, like this length is how much? 10 meter per second. And this is how much? 5. What is area of a triangle? Half into base into height.
Height.
2 goes 5 times, so it's 25. So the distance travel is not 50, but it is 25, half of that. Simple. What is the distance traveled in 5 seconds? In this case, this body is slowing down. Velocity is decreasing. It's not increasing. But doesn't matter. What are we supposed to do? Find the area under the velocity time graph in the interval 0 to 5 seconds. Okay, so which area we are supposed to find? This area here. Okay,
We have to find the area for triangle.
yeah, we need to find area for the triangle because that's the velocity time graph. So if we find area under that, like see, this is the line, this is the graph line. So area under that means below that and above x-axis. Okay, whatever area is there, that area you need to find.
125.
So half into base is 5 seconds and height is 50. So this goes 25, 125. Yeah, that's correct. Okay, all of you understood this? No problem. So what did we learn from this? From velocity time graph, if you find, like for velocity time graph, if you find the displacement, you get, if you find area under the velocity time graph, you get distance or displacement. Simple.